finishing up chapter 10, we're going to focus on what we call functional groups. Functional groups are various groups of atoms in an organic compound that cause that molecule to behave in a particular way or a predictable way. So molecules containing the same functional groups belong to the same functional group family. So basically there are thousands upon thousands of organic molecules out there. And what chemists have done is they had to figure out some way of classifying all those molecules. So they put them into groups of molecules depending upon how they behave, how they react, their properties and things like that, based upon their functional groups. So we'll talk about those. So consider these three molecules that I have. Is there something in common? What is in common with all three of these molecules? So what structural feature do each of these molecules have in common? And hopefully you said that they all have a carbon that's bonded to an oxygen, which is bonded to a hydrogen. Okay, so that's in common with all of these. So the presence of this group of atoms makes each of the molecules above belong in what we call the alcohol functional group family. So anytime you see this OH, this oxygen and hydrogen group, bonded to a hydrogen, that's what's going to make it an alcohol. If we replace the carbon with an R to represent the remainder of the molecule, no matter what it is, we get this more generic form, which is ROH. So if you look at the periodic table, you're going to notice that there are no elements with the variable R or the symbol R. So that's helpful for us. So they've chosen R to represent an alkyl group. So if I go back to the previous slide, what they've done is they said, here's my OH group, let's just call this CH3 an R, or call this ethyl branch an R, or this propyl branch an R. So when you see R, you just need to think, oh, that's a grouping of carbon and hydrogens. It's an alkyl group, or kind of the remainder of the molecule. This is the way we designate the alcohol functional group. So some other examples of alcohols. So I'm hoping you're kind of getting a feel for this, because I'm going to expect you to be able to identify what the functional groups are. So if you see an OH group bonded to a carbon, you're going to say, oh, wow, this is an alcohol group. This is an ROH. Here's the OH, so that's what makes it an alcohol. This would be considered our R. So this is the alkyl group bonded to an OH. Same thing here. So the OH is what's going to shout alcohol group. Soon we will see that all members of the alcohol family undergo similar chemical reaction patterns that differ from the reaction patterns of other functional groups. So that's one of the things that keep alcohols, in that particular in their group. They react the same way as other alcohols, but different than all the other functional groups. Consider these three molecules. And then what structural feature do each of these molecules have in common? And hopefully you can see that they all have an oxygen that's bonded to a carbon on the left and a carbon on the right. If we were to do this more generically, we would do this ROR. Okay, so this is what you're going to see a lot of, is the ROR. What my brain does, since the R is kind of confusing, is I just replace it with a C. I like to think of it more in terms of the COC than the ROC. So the presence of this group of atoms makes each of the molecules above behave as an ether functional group. So that's how you're going to identify an ether. So here are some examples of ethers. You're just going to see an oxygen, and to the left of it is bonded to a carbon, and to the right is bonded to a carbon. Here's our oxygen with, carbons bonded on each side of it. So make sure you can identify your ethers. So here are some common functional group classifications. We have these for you on your information sheet, so you don't need to go and memorize them. If you look at your information sheet, all of this is on the bottom right-hand corner. I'm telling you here that R groups are typically alkyl groups. So when you look at the R on these, once again, my brain just replaces it with a C and says to myself, if I see some C's bonded to H, that's a hydrocarbon. X is the variable for a halogen, so the 7A family of nonmetals leads us to what we call an alkyl halide. Here's that OH we just showed you on a couple slides back, which makes it an alcohol. Here's my carbon, oxygen, carbon, which makes it an ether. So I'm going to, in the next several videos, walk you through each of these functional groups. If you're making note cards, I recommend that when you start off each category, each new functional group, that you're not only paying attention to what's special about that, but make sure you're recording down the properties that I tell you and what type of reactions each one goes through. Okay, I'm actually going to tell you, you don't have to do this. You're going to have this on your information sheet, but I am going to circle some that I actually think you should memorize, because there are some reactions when we get to biochemistry. The molecules get extra large in biochemistry, and the reactions are going to be the same, simpler reactions I'm going to teach you in organic chemistry. But it's easier, I think, if you've memorized some of the functional groups. So let me tell you the ones that are going to come up over and over again in biochemistry. I recommend that you memorize an alcohol. Let me grab my pen. An alcohol and an amine, the carboxylic acid, the ester, and the amide. Okay, so those 5 come up often in reactions, and so if you get them memorized, that'll be helpful. But you don't have to. You'll always have them on your information sheet. Okay, starting off with the first functional group, the hydrocarbons. I've talked about this once before in a prelude to the alkane lecture. Hydrocarbons are just contain carbon and hydrogen. We've talked about alkanes, so hydrocarbons are broken up into alkanes, alkenes that have a carbon double bond carbon, alkynes that have the carbon triple bond carbon, and aromatics that have the benzene ring. Okay, so these are all your subsets of hydrocarbons. Alcohols and ethers. So an alcohol is going to contain a hydroxyl group. I wish I had this underlined because I do want you to be able to refer to this OH group as a hydroxyl group. So know the name of that. When you see a molecule with a hydroxyl group, you're going to say, oh, that's an alcohol. If we look at our little model over here, where the black balls are carbon, white balls are hydrogen, and the orange is oxygen, this is what the ethanol would look like, where you've got 2 carbons. So eth is the prefix for 2 carbons, so 2. And one of the hydrogens is replaced with an OH group. So ethane, replace one of the hydrogens with OH. An ether is that carbon, oxygen, carbon. So if you look at it, you're going to have an oxygen bonded between 2 carbons. Aldehydes contain a carbonyl group. So this is another word I want you to memorize. The carbonyl group is the carbon double bond oxygen. And in an aldehyde, this carbonyl group is attached to a carbon on one side and a hydrogen on the other. So here is the carbonyl group, right here, carbon double bond oxygen. And on one side we've got a hydrogen, and on the other side we have a carbon. So that's how you're going to identify the aldehyde. Ketones also have a carbonyl group. So it also has that carbon double bond oxygen, but it has carbons on each side. So here's the carbonyl group with the square around it, and we've got a carbon to the left and a carbon to the right, and that'll indicate a ketone. Carboxylic acids contain, now this is a little bit different. The other word was carbonyl. This one is carboxyl group. And a carboxyl group has the carbonyl group here and an OH group. So a hydroxyl group and the carbonyl group makes the carboxyl group. So some new vocabulary words. I would recommend some flashcards. So when you see this carbon double bond oxygen bonded to an OH, that is going to indicate you have a carboxylic acid. It's going to look similar to this here. So the carbonyl group, which is also pronounced carbonyl, so I kind of interchange those. The carbonyl group bonded to the hydroxyl group makes your hydroxyl makes your carboxyl group. It gets crazy. An ester contains the carboxyl group with a hydrogen atom replacing the carbon. So I don't necessarily see this one as a carboxyl group. I say an ester has got the carbonyl group, and then on one side it's got an oxygen, and on the other side it's got a carbon. That's how I identify the esters. Amines and amides. Both of these have got a nitrogen in them. Okay, so when you see a nitrogen, you can narrow it down to these two. You're going to know it's an amine if the functional group is just a nitrogen bonded to, and the ends of these nitrogens can either be carbons or hydrogens. It has to have at least one carbon to make it an organic molecule. If it's 3 hydrogens, it's just ammonia that we dealt with in previous chapters. So one of these ends of your nitrogen have to be a carbon to be an amine, but you can have 3 carbons, or you can have 1 carbon and 2 hydrogens, etc. So here's your picture of an amine. So this one would just replacing one of the hydrogens with an NH. In this particular case, it's an NH2. Your amides also have a nitrogen, but they have a hydroxyl group. Let's see how this is said. The hydroxyl group on the carboxylic acid is replaced by a nitrogen group. So they're starting you off with your carboxylic acid, where it has the carbonyl group and an OH here, but instead of having the OH, you replace it with an NH2, and that's how you get to your amide. I just say to myself, if I see a carbonyl group bonded to a carbon on one side and a nitrogen on the other, it's an amide. Once again, we have these on your information sheet, so if you're panicking, refer to your information sheet and make sure you can see what we're talking about there. So here's a learning check. Classify each of the following as either an alcohol, an ether, aldehyde, ketone, carboxylic acid, ester, amine, or amide. This will be easier with my pen. So on this first one, here is my OH. And it's bonded to a carbon and in just a regular old alkyl chain. So this one is an alcohol. Right here, I'm scanning across and I'm looking for something different than just carbon and hydrogens is what I'm doing. So carbon, hydrogen, I get to this oxygen. This oxygen has got a carbon to the left and a carbon to the right, so that makes it an ether. Here I'm scanning across and I get to this nitrogen. Does my nitrogen, so see, I'm going to sidestep for a second. If you see a nitrogen and it is not bonded to a carbonyl group, this is your amide. Okay? This nitrogen does not have a carbonyl group next to it, so it's just going to be an amine. Okay, this N turns into a D if this nitrogen is bonded to a carbon double bond oxygen. Here is, a lot of people might want to say this is an alcohol because there's the hydroxyl group, but the hydroxyl group is bonded to a carbonyl group. So that makes this a carboxylic acid. And I want you to know the name of a carbonyl group bonded to a hydroxyl group. This whole thing is called carboxyl. That's a carboxyl group. Okay, here's my carbonyl group, and I've got a carbon to the left and an oxygen to the right. So that's what makes this an ester. All right.